Hello guys, and welcome to day 2 of exponents. Today we are going to talk about fractional exponents. What this simply means is we will have a base raised to a power that's a fraction. And when we look at our fraction, the numerator is the power, and that's what we're going to raise it to, and the denominator is root. When we do these problems, we will do the root first, then raise to the power. But first we have to be able to change how it looks. So write as a fractional exponent. This is a square root. The square root has an index of 2. We don't normally write that there. That is just assumed. And what we need to do then is just write it as a fraction. So we have x to the power would be the first power and the second root, because that's x to the first power inside the radical, and then my root is the 2. Over here for number 2, again my power is just 1. So we have x to the 1 over 3. Here, this is a square root again. My power is 3. So it's x to the power over the root. So it's x to the 3 over 2. For number 4, we have x to the power is 2 over the root is 3. For number 5, we have x to the power is 5 over the root is 4. For number 6, we have x to the power is -1 over the root is 3. However, we're not allowed to leave negative exponents in their answers, so this becomes 1 over x to the 1/3. When we have to move our exponent to the denominator, or our whole problem to the denominator here, the fact that we have a fraction and it's negative doesn't change how we do the process. We still are going to have the exponent raised to a positive power in the denominator. But we can also go backwards and write it in radical form. This is still the power, this is still the root. So I have the 5th root in a, and we're going to raise the whole thing to the second power. For number 2, m is not being raised to a power, so it's just m. N is the only thing that's being raised to a power, and we are going to have the 3rd root raised to the second power. If you're having trouble remembering which is the power and which is the root, they're in alphabetical order, just like everything else we do, so we have power over root. For number 3, I have the first power and the 4th root. So it's no different than saying, here's my 4th root, and then just 7. I do not need to put the 1 in the problem. If you do, it's not wrong, but you don't need it. For number 4 here, the 2 is not being raised to the power, so it's 2. And then we'll have the 5th root of x to the -2 power. And we cannot leave our negative exponent, so So this is actually going to become 2 over the 5th root of x, and then the whole thing raised to the 2nd power. Well, that was just rewriting. Now we actually have to evaluate our problem. So x8 to the 1/3 power is like saying the cube root of 8 raised to the 1st power. We don't have to show that. The cube root of 8, we have to ask ourselves, is what times itself 3 times gives us 8. And the only number times itself 3 times that gives us 8 is 2, because 2 times 2 is 4, times 2 is 8. For number 2, very similar problem, except this time I have negative 8. So I have the cube root of negative 8. And this time, I have to ask myself what times itself 3 times gives me negative 8. Well, negative 2 times negative 2 gives me positive 4, and another negative 2, which gives me negative 8. So my answer is negative 2. For number 3, this is the cube root of negative 8 raised to the 4th power. We already determined that the cube root of negative 8 is negative 2. And then we have to raise that to the 4th power. Negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2. Because I have 4 negatives giving me a positive answer, so my answer is 16. So number 64 we have, or for number 4 we have 64 raised to the 1/3 power. 1/3 power is the same thing as the cube root. What times itself 3 times gives me 64. Well, that's 4 times 4 is 16, times 4 again is 64. So my answer there is 4. For number 5, we have the 4th root of 81, again raised to the 1st power. I don't have to show that. To find the 4th root of 81, we have to ask ourselves what number can we raise to the 4th power and get 81. So what number times itself 4 times will give me 81? Well, 3 times 3 is 9, times 3 is 27, times 9 again, or times 3 again, sorry, is 81. So my answer is 3. For number 6, we have 36 raised to the negative 1/2 power. Well, that's just another way of saying the square root 1/2 power. So, and since it's negative, I'm going to write it as 1 over 36 to the 1/2 power. There's a 1/2, sorry about that. So I have 1 over the square root of 36. We do not have to put that little 2 there because it's understood that if there is no 2, it's a square root. And the square root of 36 is just 6. For number 7, this is the square root of 9 raised to the 5th power. So we have the square root of 9, which is 3, raised to the 5th power, which is 3 times 3 times 3 times 3 times 3. I think I did all 5 of them, which is 243. And number 8, we have 16 raised to the negative 3/4 power. So I'll write it first without a negative exponent. So I rewrite it as just 16, and then 1 over 16 to the 3/4. which means I'm going to take the 4th root of 16 and raise it to the 3rd power. The 4th root of 16 is 2 cubed, which is 1/8. Okay. Number 9, my parentheses should actually be here, not there. Hippo, my fault. So I need to take the cube root of -8 and raise it to the -5th power, or let's rewrite that with a positive exponent. So it's 1 over -8 raised to the 5/3 power. So it's 1 over the cube root of -8 raised to the 5th power. So we'll get 1 over the cube root of -8 is a -2 to the 5th power. So it's 1 over, because it's an odd power, my answer has to be negative, and 2 to the 5th power is 32. It's 2 times 2 times 2 times 2 times 2 is 32. This one's a little bit different because I'm actually going to raise it to the fractional exponent and then multiply my answer by -1. So I have -1 times, that's the square root of 4 raised to the 5th power. So -1, the square root of 4 is 2 to the 5th power. 2 to the 5th power we discovered was 32. That's a -1. So my answer is -32. For letter D here, all we have to do is substitute in for x. And in place of x, I'm going to put 100. So I will have 2 times 100 being -3/2. First thing I need to do is get rid of my -3/2 power. So it's 2 times 1 over 100 to the 3/2 power. Here, so we'll have 2 times 1 over, that's the square root of 100 raised to the 3rd power. Well, the square root of 100 is 10, and I need to raise that to the 3rd power. So we have 2 times 1 over 10 to the 3rd power is 1,000. If you don't know the shortcut for raising 10 to the power, whatever your power is, you have 1 followed by that many zeros. So 10 to the 3rd power is 1 followed by 3 zeros because my power is 3. You weren't aware of that. So this is 2 over 1,000, which would reduce to 1 over 500. So let's try some more. Yesterday we talked about having a fraction raised to a negative power. It doesn't matter if our negative power is a fraction as well. The rule still follows that we just flip our fraction underneath, or inside, sorry, and then make our fraction, or our exponent positive. In this case it's 1/3, which is the cube root. And because my fraction is inside parentheses, I have to raise both of my numbers to the 1/3 power, or take the cube root of 27 over the cube root of 8. The cube root of 27 is 3, and the cube root of 8 is 2. Number 2 is a little bit different because my exponent isn't negative, just my number is negative. So we will have the cube root, that's my root and that's my power, of negative 27 raised to the second power. Cube root of negative 27 would be negative 3 raised to the second power is 9. We're going to go back and practice some of our simplifying. So this time we have fractional exponents. Remember, if there is no exponent, the exponent is actually 1. And when I divide, I subtract exponents. So I will have x to the 1 minus 1/2. So I have x to the 1/2 power. I'll rewrite that. I don't know how that works. So x to the 1/2 power. Now, for number 2, we can rewrite this as x to the 9, y to the 12, raised to the power over root, so it's 1/3 power, and then simply multiply because I have a power to the power. So 9 times 1/3 is 3, and 12 times 1/3 is 4. The other way to look at it is 9 divided by 3 is 9, and 12 divided by 3 is 4. Earlier in the year we did problems like this, and when we did this we just divided by the root. We just didn't color. For number 3, it's still a division problem. So it's m to the 3/2 minus 7/2. So I have m. 3 minus 7 is negative 4 over 2. We have m, and I divide, I get negative 2. Can't leave our negative exponent, so we have 1 over m squared. Number 4 is going to be very similar to the problem we just did on the page previous to this, which is number 2. And it's m to the 8, n to the 20th, raised to the 1/4 power. And again, just follow your rules for power to power, you multiply. 8 times the 4th is 2. 20 times the 4th is 5. 8 divided by 4 is 2. 20 divided by 4 is 5. Sorry about that. Alright. Still dividing. So my rules are still the same. I still subtract. N to the negative 1/2 minus a negative 2. Minus a negative makes it plus. And if I have a negative 1/2 plus 2, I will actually get a positive 3/2, because 2 minus a half is 1/2, and 1/2 is 3/2. You need me to here, 1/2 plus my common denominator is 2. So multiply top and bottom by 2, so I get 4. So negative 1 plus 4 is 3/2. Hope you were able to follow along today and that this was a little bit better. It was a little bit shorter. Thank you again, and I will see you in class tomorrow.